Hello, in this video we'll be finding the standard equation of the parabola given certain conditions. So the first example here we have the focus of 0, 2. So let's find the focus 0, 2 in here. So here is f 0, 2, and then the directrix is y equal negative 4. So this will be horizontal line, y equal minus 4. And to find the equation of parabola, we need to remember that the vertex lay between the focus and the directrix halfway. And so the halfway, the vertex, since there are 6 units here, halfway is 3 units. So I count 3 units from the focus or from the directrix, and that will be the vertex. So the vertex in our case here is for the x is 0 and the y is negative 1. And the parabola will pass the point or the line segment here of the focal diameter. Usually the length of the focal diameter is equal to 4p, and the absolute value of p. So p in this case, the absolute value of p is the distance from the focus to vertex, or the distance from the vertex to the directrix. So the distance is 3, and we see that this parabola is going to open upward because the focus is always inside the parabola. So it's going to open upward, therefore p is positive number. So p is equal to 3. So the focal diameter will be 4 times 3 will be 12. So this distance, that the line segment that passes the focus, is 12. So that means we count 6 from one side and 6 units on the other side. So I know that this parabola is going to pass by this point here and this point here. So again, let me show that this is for absolute value of p, in our case is 12. So we have 6 units in one side, 6 units in the other side. Now all what we need to do is to find the equation. So the equation here, v basically is h, k, so h is 0 and k is negative 1. And the equation says, because it opens upward, so it's going to be x squared. So we have x minus h quantity square is equal to 4p y minus k. In our case, h is 0. And p we already know it's 3, so 4 times 3 is 12. And then we have y minus negative 1, which is x squared equal 12y plus 1. And this is the equation that corresponds to the given condition of this parabola. Let's see another example. In this case, what was given is the vertex of negative 1, 1. So I'll find this point on the graph, v negative 1, 1. And the focus of negative 3, 1. Now we know that p is the distance between the focus and the vertex, and I didn't count so negative 3 is right here, so the distance between here is equal to 2. So it tells me that the distance from the vertex to the directrix is also 2 units. So the directrix, if I graph it, is a vertical line, x equal to 1. This is 1 here. X equal to 1. So given these conditions, we know that the parabola will open to the left this way. So finding the focal diameter will help us know where this parabola exactly gonna pass, what other 2 points. So we know that the length of the focal diameter is equal to 4p. I put absolute value because it's a p usually can be positive or negative, but here we're talking about distance. It's always positive. So 4 times 2 would be 8. So this distance here is 8, so halfway will be 4. So here is 4 units from the focus, another 4 units from the focus. So graphing this parabola will be this way. So as we see, this parabola is opening to the left, so it's gonna be y squared, or basically y minus k quantity square equal 4p h minus 8 x minus h. And because it's opening to the left, we know that p is negative. So the distance, the unit distance for p is equal to 2, and therefore p is negative 2. The absolute value we know it's 2, but the p is negative since this parabola is opening to the left. So y minus, again this is h and this is k, y minus 1 quantity square is equal to 4 times negative 2 x minus 1, which is plus 1. So here we have y minus 1 quantity square is equal minus 8 x plus 1, and this is the equation of this parabola with these 2 given conditions. And I hope this is helpful.